Good morning, student. I hope you are happy and with good health at your home. You can also say to me good morning by only the process of subscribe my channel and give likes. Okay, my dear student, we have started our concept continuity with limit. You can say limit and continuity. So we have discussed about continuity of a function when a function is continuous. Now some more example about continuity and discontinuity also. Now in our first example, if fx have sin 3x upon x if x is not equal to 0 and 2x plus 3 if x is equal to 0, check the continuity. Okay, so now first we will take when f0, then we have 2x plus 3. When f0, then we have 2x plus 3, but at the place of 0 first we will write here x. Now we will put 0, then f0 is 2 into 0 plus 3. So you know 2 into 0, 0 plus 3 is 3. Now limit x tends to 0, x approach to 0, fx. You know limit means, if limit x tends to 0 means x is not equal to 0, x approaches to 0, x approaches to 0. It means x is not equal to 0, then function is sin 3x by x. Now in plus 1 we have discussed about sandwich theorem. By using circular system we have proved that limit x tends to 0, sin x upon x is equal to 1. So same here, if we put direct 0 then is not possible, it can be changed into 0 by 0 something form. If x tends to 0, sin 3x by 3 by x, so we will make such condition. Here 3x in theta, in denominator also 3x, so we will divide by 3 and also multiply by 3. If you know if x tends to 0, then 3x is also tends to 0. So in next step, limit 3x tends to 0. 3 is constant, we will take it outside, and sin 3x upon 3x is equal to 1. So we have 3 into 1 is 3. So now you can see f0 is 3 and f limit x tends to 0 is also 3. Now f0 equal to limit x tends to 0 fx. Therefore function is continuous. Function is continuous because we have a property in such type condition, if limit x tends to 0 fx is equal to f0, either you can say fx tends to a equal to fa, then function is continuous. Now in second example, if fx is x square minus 1 upon x minus 1 in case of x is not equal to 1, and 2 if x is equal to 1, check at x is equal to 1. In same process we will follow the property fa is equal to limit x tends to a fx. Okay, by this process a is 1, our limit at 1. First we will find f1. Now the fx is 2. Fx is 2 when x is equal to 1. So f1 is also 2. Okay. Now limit x tends to 1, fx is limit x tends to 1, fx is fx बेटे here क्या है x square minus 1 upon x minus 1. If we will put here 1, then 1 minus 1, 1 minus 1, 0 by 0. That is meaningless. So in such condition, if we have a result is meaningless, so we will follow either factorization, either rationalization, or something a plus h, a minus h. So we will make a factor limit x tends to 1. Our factorization is x minus 1, x plus 1 upon x minus 1. Both will cancel. Now you can put limit 1 plus 1 is 2. So you can see here fx is also 2. Limit x tends to 1 is also 2. So now result is f1 equal to limit x tends to 1 fx. Therefore fx is continuous. Fx is continuous. So by this method we will check about the continuity of a function. Now another example. Now in next example, a function 2x plus 3 if x is less than equal to 2, and 2x minus 3 if x is greater than 2, and at x is equal to 2. We want to check its continuity. So it is the case of inequality. Inequality we have discussed, we are using two types. Two types means left hand limit x tends to a minus, right hand limit x tends to a plus, or either fa. We will find left hand limit, right hand limit, and direct fa. If all are equal, then function is continuous. So in this process, left hand limit meaning less than a. X tends to a minus means less than a. So how left hand limit x tends to 2 minus. So x is less than from 2 minus. So x is less than from 2 is 2x plus 3. Fx is 2x plus 3. So we will change into a fixed interval at h. So let x put as 2 minus h. X is equal to 2 minus h. Now if x tends to 2, then we will put here 2 minus h, 2 minus 2, 0. It means h tends to 0. So in this case, limit h tends to 0 and x as 2 minus h plus 3 multiply by 2 limit h tends to 0 4 minus 2h plus 3. If h is 0, then result is 4 plus 3, that is 7. 4 plus 3, that is 7. So it is our left hand limit. So keep in mind our left limit is 7. Now right hand limit. Right hand limit. Right hand limit. Limit x tends to 2 plus. Right means 2 plus. You can see also it is 2. So 2 less meaning left or 2 more meaning right. Right hand limit is 2 plus, greater than 2. If fx is greater than 2, then we have limit x tends to 2 plus 2x minus 3. Now we will put x is equal to 2 plus h. Now if x tends to 2, then 2 is equal to 2 plus h means h tends to 0. So limit h tends to 0, 2 into 2 plus h minus 3. Limit h tends to 0, 4 plus 2h minus 3. It means if h tends to 0, 4 minus 3 is 1. So now our right hand limit is x tends to 2 plus, that is 1. And third part is FA. FA means our limit at which point? At 2. So we will find F2. F2 means equal to 2. Or you can see with a equal to 2 here. It means in function 2x plus 3. First we will write fx, that is 2x plus 3. Now our f2 is 2 into 2 plus 3, that is 7. Now you can see left hand limit, limit x tends to 2 minus fx, right hand limit, limit x tends to 2 plus are not equal. It means function is discontinuous. Function is discontinuous. Is it clear? So in case of continuity or discontinuity, we have two types. We have two types question are there. In two types, which two types? Fx is, one is case of not equal and equal, and another case is greater than equal to less, either only greater, less than equal to, or greater than equal to, less than also. So in such type condition we are using the method FA and limit x tends to a fx. Okay, but in such condition we are using left hand limit, right hand limit and FA. Some example of modulus function. In this case, some example of modulus function also can be changed in this type. So we will discuss one example of modulus function. Now we have example of a modulus function. So you will see if x is not equal to 5, this part, and x is equal to 5 is 1. So you know about modulus function. If x is greater than equal to 0, then modulus x is positive x, and if x is less than 0, then modulus x is negative x. In the same way, here limit is 5. When modulus x minus 5 is positive x minus 5, when x is greater than equal to 5, and modulus x minus 5 is negative when x is less than 5. When x is less than 5, when x is less than 5, then it is negative, greater than equal to then positive. So we will change it. Fx, when x is greater than equal to 5, modulus x minus 5 is positive. Denominator is also positive. It means both cancel, it is 1. When x is less than 5, when x is less than 5, when x is less than 5, then it is negative. Then it is minus 1. Here x is equal to 5 is 1, so we have included here x is equal to 5 is 1. So now our refined function is 1 when x is greater than equal to 5, minus 1 when x is less than 5. Now you can solve by using left hand limit and right hand limit. Left hand limit and right hand limit. But you can see directly also in the right 1 or in left minus 1. The function is discontinuous. But is a constant values, so we will discuss here. At x is equal to 5, left hand limit. Left hand limit, limit x tends to 5 minus fx, that is limit x tends to 5 minus less than 5. 5 minus is minus 1. So a constant value you can write directly minus 1. Right hand limit, limit x tends to 5 plus. In case of 5 plus greater than 5, it means it is also 1, and f5 is also 1. So you can say left and right hand not equal. The function is discontinuous. Now we will discuss more example. Now our question is, for what value of x, for what value of k, fx is continuous. Fx is continuous. Question is, if fx x square minus 2x minus 3 upon x plus 1 and x is not equal to minus 1, and k when x is equal to minus 1. So for what value of k our function is continuous. So by the same process we will apply when fx is k also. When x is minus 1, then it is also k. And limit x tends to minus 1. Limit x tends to minus 1, then function is limit x tends to minus 1 x square minus 2x minus 3 upon x plus 1. If we put direct minus 1, then result is 1 plus 2 minus 3 minus 1 plus 1. It is 0 by 0, meaningless. So we will make its factor, and by using split the middle term, splitting the middle term, you can make its factor. multiply is minus 3, sum is 2, and it is minus 3x plus x, and limit x tends to minus 1. If x is common, x minus 3, plus 1 is common, x minus 3, x plus 1. Here is 1. Now limit x tends to minus 1, x minus 3, x plus 1 upon x plus 1. Limit x tends to minus 1, x minus 3. Now you can put here minus 1. It is minus 4. And f minus 1 is k. Now function is continuous. So if function is continuous, then fa is equal to limit x tends to a fx. It means k is equal to minus 4. Now when function is continuous, so we can find the value of and define values. You can see where it is variable, scalar constant k, whose value is minus 4. Then another example. Now we have another example. Check the continuity at x is equal to 0, in which x is greater than equal to 0, equal to 0, and less than 0. In this question, we will use the method left hand limit, right hand limit, and fa. So, my dear student, at x is equal to 0, left hand limit meaning limit x tends to 0 minus, means less than 0. Less than 0 is our function x upon 1 minus 1 minus x. X upon 1 minus 1 minus x. Now we have x tends to 0 minus. So we will put here x is equal to 0 minus h. If x tends to 0, then h is also tends to 0. Now in this case, limit h tends to 0, x has 0 minus h, so we have limit h tends to 0 minus h upon 1 minus 1 plus h. Now if you will put here 0, then 0 upon 1 minus 1, 0 by 0, meaningless. In such condition, if result is meaningless, so we will make factorization, but factorization is not possible here. So we will do rationalize. In this case, limit h tends to 0 minus h upon 1 minus 1 plus h, then multiplied by 1 plus under the root 1 plus h, because here negative we will take positive. 1 plus under the root 1 plus h. Limit h tends to 0 minus h into 1 plus h, a minus b, a plus b, a square minus b square. So you may square root, cancel. Then limit h tends to 0 minus h into 1 plus h upon 1 minus h. Minus 1 plus 1 cancel, minus h to minus h cancel. Now you can put here 0. The result is 1 plus 0. It means 1 plus 1, that is 2. So our left hand limit x tends to 0 minus fx, result is 2. fx result is 2. Now we will discuss right hand limit. In the right hand limit x tends to 0 plus. Now 0 plus means greater than 0. We have sin x upon x plus cos x. In this case we would put x is equal to 0 plus h. So limit h tends to 0, sin 0 plus h upon 0 plus h, limit h tends to 0, cos 0 plus h. Here limit h tends to 0, sin 0 plus h, sin h upon h, or limit h tends to 0, cos h. So you know is equal to 1, and cos 0 is also 1, 1 is 2. Okay, so our right hand limit is also 2. Limit x tends to 0 plus fx is also 2. Left is also 2. Right is also 2. And f0 is also 2. Now you will see left hand limit equal to right hand limit equal to fa. Therefore function is continuous. Yes, but now next example. If a function have ax plus b when x is greater than 2, 7x minus 4 when x is equal to 2, 3x minus 2b if x is less than 2, is continuous at x is equal to 2, then find the value of a and b. Now we have function is continuous. So we will start by using the same method, left hand limit. Limit x tends to 2 minus. Now fx. Limit x tends to 2 minus fx when x is less than 2. 2 minus x is less than 2 meaning 3ax minus 2b. Now 2 minus, so we will put here x as 2 minus h. X as 2 minus h. And if x tends to 2, then h tends to 0. So in left hand limit h tends to 0, 3a into 2 minus h minus 2b. That is limit h tends to 0, 6a minus 3ah minus 2b. Now h is 0. This part will 0, then the result is 6a minus 2b. It is left hand limit. Now right hand limit x tends to 2 plus. Limit x tends to 2 plus. 2 plus greater than 2. What is greater than 2? Ax plus b. Now here also we will put x as 2 plus h. If x tends to 2, h tends to 0. We have limit h tends to 0, a into 2 plus h plus b. That is 2a plus 2h plus b. If h is 0, then result is 2a plus b. Now right hand limit 2a plus b, left hand limit 6a minus 2b. Okay, we have left hand limit and right hand limit, and equal to 2 also. Equal to 2. So keep in mind left and right. f2, now fx is 7x minus 4, then f2 is 7 into 2 minus 4. It is 10. It is 10. So now we know that if fx is continuous, then left hand limit x tends to a minus equal to right hand limit x tends to a plus equal to fa. So by the same condition, listen again, if function is continuous, then left hand limit equal to right hand limit equal to fa. By the same condition, our left hand limit is 6a minus 2b. The right hand limit is 2a plus b. And f2 is 10. Okay, therefore 6a minus 2b equal to a plus b equal to 10. Now, if 6a minus 2b is equal to 10, same way 2a plus b is also 10. Now you will solve both the equation by using elimination method, cross multiplication method. Now here 6a, here 2a, yeah, here 2b, here b. So we will multiply equation 2 by 2. Multiply by 2. So 2 2 is 4a plus 2b is equal to 20. It is 3. Now 1 minus 1 plus 3. You will add first and third. 6a minus 2b 10. 4a plus 2b 20. Minus 2b plus 2b cancel. 10a is equal to 30. Then divide by 10. A is equal to 3. Putting the value of a in first, 6 into 3 minus 2b is 10. 18 minus 2b is 10. Minus 2b is 10 minus 18. Minus 8. Now b as 8 by 2. That is 4. B is 4, A is 3. Okay. So my dear student, today you will complete exercise 6.1 in element also. And some students are not sending pic of your homework. So you should do at your home. And you are doing well also. Okay. You are doing well also. Only the online interaction, your work is so good. I have checked many student answer sheet. So my dear student, good morning, and like and subscribe our channel. Stay home, stay safe.